here we have 4 players, right? And the action on each player is AXB or AYB. Now, since we have 4 players, so we have like, the form would be like, player 1 and then player 2 here, player 1, player 2, and then this would be like, player 3 with, this will be player 3, and then this again for the same thing as this, and then okay, so this is like, the 2 actions of player 3, and then I have here player 4, 1 for this and 1 exactly the same as that. Yeah, so that's how it looks like. So the strategic form would is now this one. Okay, right, so the strategic form is now this one. So if all the 4 are going with AXB, then the total time would be this. Okay, so you have to keep in mind that the total time for all 4 of them would be like, 15 plus 22.7, and that's 37.7. Now you have to fill in this this thing, right? This table. So this whole thing is for P4 picking AXB, and this thing is for P4 picking AYB, right? And this side here is for P3 player 3 picking AXB, and this is for player 3 picking AYB, right? And the same thing goes here. Player 3 picks AXB, and here player 3 picks AYB. So this is how it looks like. Now, to get the Nash equilibrium, right? So to get the Nash equilibrium, so say for each of this one here, okay, we say between 37.5 and 26, player 1 will prefer 37.5. Yeah, right, so player 1 will prefer 37.5 and then player 2 would prefer 37.7. No, here the number, okay, player 1 will prefer 26 because 26 is shorter commute than 37. Okay, the smaller number here is the better. Here between 37 versus 26, player 2 will prefer 26. Okay, and then between 37 between 37.7 and the other one here, the 26 here, okay, player 3 will prefer the 26. And then between 37.7 here and the 26 here, player 4 will prefer the 26. You see that? Okay, and then you do it for all of them. Here I'm putting a bold number for the preferred choice. Okay, and so when you do that, you see that this is the Nash equilibrium, right? These are the Nash equilibrium here, there, this one, and this one. So those are player 1 playing AXB. Okay, here player 1 playing AYB, player 2 playing AYB, okay, and then player 3 playing AXB, and player 4 playing AXB. This would be it. This one here would be this. Okay, 1 is playing AYB, 2 is playing AYB. Oh no, this one. Okay, so this one would be AYB, AXB, and then player 3 is AYB, and player 4 is AXB. Okay, that one. So just identify all of them in here. So there are four Nash equilibriums here, and when you think about it, this is the situation when two are playing AXY and two are playing AYB. I mean, two are playing AXB and two are playing two are using AXB and two are playing AYB. Now, to answer the question, if all four are taking the same route, is there incentive for somebody to deviate? Yeah. Okay, let's look at that thing, right? All four are taking the same route. So we're talking about, this one, right? All four are taking AXB. So when all four are taking AXB, you see, player 1 wants to deviate to get 26. Player 2 wants to deviate to get 26, and so on, right? So everybody has an incentive to deviate. The same thing goes here. When everybody is going through the AYB, everybody also has the incentive to deviate. If three take the same route, okay, three people are on the same route, while the other one is, alone in one route. Okay, so any one of the three will have the incentive to deviate. Okay, so let's have an example of that. Okay, let's have an example of that. Say three people are on the same route. Let's say this one. Okay, so let's say this one. Three people are on the same route. That would be this, right? Here, one is using AXB. Player 3 is using AXB. Player 4 is also using AXB. So, they have the same travel time. And then only player 2 is using AYB. Now here, you see that player 1 has the incentive to deviate and go to AYB. And that will cut his travel time to 30. Right? The same can be said to the other two players. If two take each route, there's no incentive to deviate. Okay, so just like this one here, the Nash equilibrium. Okay, like this one here, two people are taking AXB and two people are taking AYB, right? Okay, so there's no incentive for anyone to deviate because, if player 1 deviates to AXB, he'll be getting 33.8. Okay, and this wears off. If player 2 deviates, he'll be getting 34 instead of 29.9. So there's no incentive for anybody here to deviate. So there's a lot of numbers here, and you have to go through all of them. Now, the next question here is this. Now, if there is a bridge from X going to Y, right? Then there will be four players, player 1 to player 4, and each player now has four actions. Okay, AXB, AYB, AXYB, right? And then so AXB would be this. Okay, AXB would be this, AYB would be this, AXYB would be, this, AYXB would be this. Okay, which is obviously longer. So here you can make a table like this, but each of the table here will have four actions. It's going to be very big. Yeah, okay. And then we don't want to do that. Okay, so to get the Nash equilibrium, you have to really think clearly here, right? The Nash equilibrium here is that two players are going AXY, two players are doing the AXYB route, right? And then one is on AXB and one is on AYB, okay? If you think about it, the two players are just going through the AXYB route will have, 26 minutes of travel time, yeah? right? So it will be, since there's two players in the AXYB route, they have 26 minutes of travel time. This will be 9 plus, 8 plus 9, okay? And it's going to be 26. And then the one, this is the AXYB, okay? So there's two players, two of them. And the one going to the AYB route, there's only one person, right? So it's going to be doing 20 plus 6, which is 26. And then the other one going through this route, AXB, will have a travel time of 6 plus 20, which is 26 as well. These are the lowest possible times that you can think of. And here you can see easily that, there's no one has the incentive to deviate, okay? And so that's the Nash equilibrium. You can list all the possible, configurations, and there should be 12 of them, okay? There should be 12 of them, such that 2 are on AXYB, and one is on AXB and one is on AYB. All right. Okay, so now let's go to exercise 42.1. All right, so in this one, we are going to, okay, so you have the utility of 1 and then utility of 2, right? Take the derivative of u1 with respect to a1 and equate it to 0, okay? And then do the same for utility of 2. Take the derivative of that with respect to a2 and equate it to 0, okay? And then here, you'll have a1 as a function of a2, and then here you'll have a2 as a function of a1, okay? Now you substitute this one in here, okay, and then do the math, and then you'll have a1 and a2, okay? You'll see that a1 here will have 1/5 and a2 is 2/5. So it's just, math. Exercise 44.1. So again here, the payoff for any person is this, okay? So this is the payoff for any person, okay? UI is equal to this. The notation can be terrible, but that's not really a problem, right? So if there's only two people, okay, if there's only two persons, then you can see that U1 would be W1 plus C2 plus W1 minus C1 plus times C1 plus C2. Okay, just follow this thing that he's saying, right? Here, you're making I is equal to 1, okay? If I equals 1, then you have that, okay? Now, take the derivative of U1 with respect to C1 and set it equal to 0, and you will have this, okay? And then you will have C1 is equal to W minus C2 all over 2. Now, do the same function again for I equals 2, okay? For I equals 2, right? Keeping in mind that W1 equals W2 equals W, right? They're just going to be W. So there's no subscript for W anymore. Take the derivative again with respect to C2, and then you will have another C2 as a function of C1, right? And then solve this one here and put it here, and then solve for C1, and you get this. C1 star is W all over 3, and then C2 will be W over 3. So the Nash equilibrium is that the two are going to pick W over 3. Okay? And now substitute that back in the utility function, right? Substitute that back. Okay, C1 is W3, substitute it back. Okay, so you'll find that the utility for 1 would be equal to this. You do the same thing for U2. Okay, you'll find that the utility for 2 will be equal to this. Right. Now you want to compare it to the case where everybody's paying half, okay? Half of their wealth. If everybody's contributing half of their wealth, then